Hello, welcome to this AWS webinar. My name's Ian Massingham. I'm a technical evangelist with Amazon Web Services based here in Europe, and I'm going to be your host for this session today. It's going to be a deep dive into the newly announced AWS IoT service, which we announced at AWS reInvent in October this year. The objective of this session is to dive deep into this service and help you understand a little bit more how developers can use this service to build connected device applications using the AWS platform. Before we kick off with the content, just want to draw your attention to a couple of things that you can see in the live webinar interface. If you're joining us on demand, of course, on YouTube, these features won't be available to you. But in the on-demand video description, you will find a link to a copy of the slides from this session, which have been shared on SlideShare. You can download a PDF from there. If you are watching live, you'll see a couple of things in the interface. The first is the Q&A panel. You can submit any questions that you might have during today's session using that Q&A panel. I'll do my very best to answer them at the end of today's session. And secondly, in the Files panel, you can access a download of a PDF which contains the slides from this webinar. So please grab a copy of the PDF and please do ask any questions at all that you have during today's session. If you are watching this on demand, I do regularly check comments on these videos. So if you do have questions about the on-demand version of this session, please feel free to submit a comment in YouTube in the comments, and I'll do my best to answer questions there as well as they accumulate over time. Okay, so let's get on. Why did AWS decide to launch the AWS IoT service? So there are some challenges, some undifferentiated heavy lifting that's associated with developing IoT applications. And these challenges really can detract from the focus that developers can place on the unique core functionality of the applications that they're trying to build. And in launching the AWS IoT service, we're trying to shoulder some of that heavy lifting so that developers can spend more time focusing on the unique value-added components of their app and spend less time on worrying about some of the heavy lifting associated with operating the platform that's required to build IoT apps. So things like alternate protocols, which we're going to cover in this session in a little bit of detail, scalability and extracting valuable data from the noise that can arise with connected device applications, security and management of endpoints and of connections, integration with cloud applications, mobile apps and analytics, and of course dealing with the on-device SDKs that are required to build and connect applications to IoT backend services. These are components that customers have told us aren't that valuable to them, components that they'd like AWS to focus on to enable them to spend more time focusing on the core and unique components of their app. And the platform that I'm going to take you through over the course of today's session, we feel addresses many of these low-level challenges that developers have had to deal with. And then ultimately what we're trying to do with AWS IoT is make it possible for developers to securely connect devices to AWS so they can interact with applications and other services and other devices. And to make it simple for developers to scale from one device to 1 billion devices without having to be too concerned with these low-level platform features that are required to enable that. So we created and launched the AWS IoT service in order to help developers achieve these objectives. And we announced this, as I said at the top of the session, at AWS reInvent early this year in Las Vegas. And it was our CTO, Werner Vogels, that made the announcement. I just want to talk you through the core components of the AWS IoT service so you can understand a little bit more about what we're providing to developers and how they can make use of the service. So the first important component is the device gateway. And this device gateway enables client devices that are running the AWS device SDK, and we'll talk about the different options that are available to developers out on the device later in today's session, to communicate with the AWS IoT service. We provide a set of authentication and authorization features and services that can be used to obviously authenticate and secure transport of data between those clients, and there can be many hundreds of thousands, millions, or even billions of clients connected in a secure way to that device gateway, able to communicate using protocols like MQTT or HTTP for communication. Back in the platform, we have a rules engine. This enables messages to be transformed based on rules that developers will configure. and you can route these messages to AWS services on the basis of rules that you create in that engine. This allows for integration with familiar AWS services like DynamoDB or AWS Lambda and others, as well as with third-party services that developers may wish to connect with, including external HTTP-based services, and we'll talk about that a little bit later in today's session. We also provide a device shadow capability, and this provides a persistent state for things, which is very important. Obviously, if you're working with intermittent connectivity, maybe your device is deployed in a rural location that has intermittent or patchy GPRS or cellular data coverage. And you want to be able to work with that device, setting state on that device and reading from that device when it may not be connected due to, say, topological factors. Maybe the device is behind a hill and has intermittent radio connectivity. And the device shadow allows applications to work with a virtual representation of the device, which is maintained within the AWS cloud, and not have to take account of the fact that the device may not be connected at the point that the developer wishes to read or write state from the device. When the device connects again, state will be synchronized at that point. So the things in the yellow box that you can see here represent the components that are provided by the AWS IoT service and can be controlled using the AWS IoT API. And then the things outside the box are either other AWS services, applications that developers themselves might build, and of course the devices and the associated device SDKs which are out in the field. The final component of the service is the device registry, which can be used to manage identity of the things that you're going to connect to this service. And as with the others, we're going to dive into each of these components in a little bit more detail now, explain their function and the role that they play for developers that are building IoT applications using this service. So the first important component is the AWS IoT message broker. And as we mentioned earlier, this is a device gateway that enables communication with devices using MQTT and the HTTP protocol. And I'm sure that you're very familiar with the HTTP protocol. That is the protocol of the web, of course. And we're going to talk a little bit more about MQTT in just a few minutes. But we support both of these standard protocols. And the gateway provides a powerful pub-sub broker for long-lived bidirectional message flows. So it enables clients to send data to the service via the gateway, and also enables the gateway to communicate in the reverse through the same channel to send state back to the devices on demand. The gateway provides security by default using X509 certificates and a protocol called TLS 1.2 client mutual authentication, which requires a certificate on the device and a certificate on the gateway to enable bidirectional authentication of the devices before authorized communications can take place. And we provide for a topic-based architecture, so you can essentially subscribe to topics via the gateway, and when subscribing to a topic, you will then receive messages in the topic that you are subscribed to. Now, the MQTT protocol is worth focusing on a little bit more detail. This is a standard protocol which is lightweight and is ideal for pub-sub transport for connected devices. It's already widely used in many sensitive and resource-sensitive scenarios. But historically, customers have needed to understand how to build, maintain, and scale a broker to use MQTT with client applications. And one of the key functions of the device gateway that AWS provides as a component of this IoT service is to take responsibility for that scaling and maintenance of the MQTT transport endpoint for customers, making it simple for them to make use of this lightweight communications protocol to send and receive updates and data from the connected devices that form the client-side component of any IoT application. MQTT is a very useful protocol for low-power use cases. There's some data here on the right-hand side of this slide that you can see. Maybe the most noticeable stat there is the fact that it takes 170 times less power to receive data using MQTT than it does to receive data using HTTPS endpoints. So it's very much more power efficient. It's very important for building sealed unit IoT devices where you want to have minimal servicing requirements and the maximum possible lifespan for devices that are out in the field. So MQTT is a really useful tool to use for that particular use case. The gateway itself has been designed with scalability in mind and is very capable of supporting millions of devices, sending billions of messages. And we'll talk later about some of the functionalities provided by other services that are connected to the gateway upstream. But we'll move on now and talk a little bit about the IoT security features that are provided by the AWS IoT service. And as I said earlier, we provide mutual authentication and encryption at all points of the connection between device and the gateway, so that data is never exchanged between devices and AWS IoT without proven identity. We support the AWS method of authentication, which is known as SIG v4, as well as X509 certificate-based authentication. Connections using HTTP can use either of those methods. Connections using MQTT are limited to mutual auth TLS, where you'll have certificates on the device and certificates on the gateway that are used to authenticate the connection bidirectionally before any traffic is exchanged over a TLS encrypted link. Okay. It's worth just talking a little bit about this mutual auth process and how it differs from traditional HTTP authentication that you'll use with HTTPS transport. So the top model would be a server-based model where your browser client or your HTTP client in this case is communicating with a server. It's a certificate on the server end, but there is no certificate on the client. With the mutual auth used in conjunction with TLS, actually with either protocol, but exclusively used with MQTT. The situation is rather different, and you have certificates and keys on both ends of the connection. These are used to mutually authenticate both the device and the gateway, hence the name Mutual Auth TLS. Take a look now at provisioning and security controls for devices. And this can be a relatively challenging area for developers that are creating connected device applications. The reason for this being, of course, that you may need to create and deploy significant numbers of certificates and keys that are unique to individual devices. And doing this manually could be a time-consuming and error-prone process. And to simplify this, as well as the manual process that's available via the AWS console, we also provide a set of APIs that developers can use to programmatically control the AWS IoT service. And one of these APIs also supports the AWS CLI tool, which again has full support for the AWS IoT service. And these control mechanisms allow you to provision, activate, and associate device certificates with the relevant policies that are going to control access to the AWS IoT service for specific devices. As well as provisioning, this mechanism also allows you to instantly revoke access for individual devices should you choose to do so. And in addition, AWS IoT also supports connections from users' mobile apps using the Amazon Cognito Identity Management Service. And Amazon Cognito itself can take care of all of the steps necessary to create a unique identifier for your users' apps and to retrieve temporary and limited privilege AWS credentials for IoT applications that you may be running on mobile devices, IoT or Android devices, for example. iOS or Android devices, for example. And so that's provisioning, security, and deprovisioning. The rules engine, which we touched upon earlier, the basics of this are that it provides a simple and familiar syntax where you can use SQL statements to define topic filters. And you will recall that we mentioned earlier that devices themselves publish notifications to topics, and you can then apply filters to these topics, where clauses, and there's some advanced support for JSON in the engine also. And there's a number of built-in functions here that you can use to improve the signal-to-noise ratio in applications, working on state data that is going to be provided to you from your devices via the SDKs that are deployed on them, state data sent to topics, and then you can manipulate that using string manipulation functions with regular expressions. You can operate on it mathematically to calculate sums and running totals, for example. You can use context-based helper functions, cryptographic support, and you also have a number of, let's call them quality of life functions like timestamping, random number generation, and the like. And the rules engine itself can enable you to build device-based applications without having to place any logic on the devices. There's a very simple example here where you might want to operate when certain state data is received from one device. So say somebody presses a button on one of your devices which generates a state data snippet that says that the color is red. Well, you could build a rule in the rules engine to flip a secondary device so that when that state change is received, the secondary device is updated and changes color itself. And there's no need for you to run any compute resources to do this. The rules engine will take care of the logic and message routing on your behalf so that you don't have to maintain any service components to do that. This obviously can become very, very important if you need to do complex evaluations across large fleets of devices rather than single units. There are dozens of functions available, and you're also able to take multiple actions, so you're not just restricted to a single action. You're able to do a variety of different things, operating on different attributes within your state data and taking different actions on each one of those attributes. For example, firing functions, persisting data in databases, or updating dashboards that might be rendered on mobile devices. So you had a lot of functionality available to you within the rules engine without having to resort to other services. But if you do need to do that, you need to build something which can't be handled inherently within the rules engine. The rules engine itself is a mechanism for connecting AWS IoT both to external endpoints and to other AWS services. And if you kept up with AWS for any period of time, many of these services will be very familiar to you. You can also channel data via these services into other AWS services that might act as persistent stores for you. And doing this using Amazon Kinesis is obviously a reliable mechanism for streaming data from the AWS IoT service into long-term data stores. You can also, as a third option, trigger and make use of external endpoints using AWS Lambda to invoke functions in Lambda, which we'll demonstrate to you later in today's session, which might trigger external endpoints, or using SNS to trigger HTTP protocol requests containing data gathered from rule triggers within that rules engine. So recapping again, the rules engine evaluates inbound messages published into AWS IoT, optionally transforming them and delivering them to the appropriate endpoint based on business rules that application developers specify, and you can reach those external endpoints via Lambda and the AWS Simple Notification Service. You have a variety of different actions available to you, which we will show you later on in a very quick demo. Using SNS, as I mentioned earlier, gives a couple of options. You can use SNS for push notifications, so direct to a variety of different mobile platforms to enable you to trigger push notifications on the basis of rules within the AWS IoT rules engine being triggered. And you can also use SNS, as I said a second ago, to communicate directly with a HTTP endpoint, or for that matter, SMS or email. And you can call HTTP-based third-party endpoints through SNS with subscription and retry support. So if you do need to work with a third-party HTTP service endpoint, SNS is a protocol transport mechanism that you can use to do that in a reliable way with appropriate support for retry. Okay, let's move on now and take a look at a quick demo. Before we do that, I'm just going to introduce to you the subject of this demo, which is a device that we gave away to developers that participated in several of the IoT sessions at this year's AWS reInvent. It's a device called the AWS IoT button, and it's intended to provide developers with a very simple mechanism that enables them to get started with the AWS IoT service. It's essentially a stateless Wi-Fi button based on the same hardware platform as the Amazon Dash button. It enables you to excuse me, enables you to execute code in the AWS cloud with no device-specific code or flashing required. And it offers a very simple mechanism for learning how to work with rules, shadows, and topics. And the intent here really was to stimulate and enable developers to build cool stuff using the AWS IoT service. Some of the examples that we showed during sessions at AWS reInvent, when we showed this, which was the button being used to trigger a rule in the rules engine, fire a Lambda function and call an external HTTP service endpoint, in this case for Twilio, an AWS technology partner that provides VoIP and SMS services. In demonstrating this particular application process flow, we're able to show developers' use of the SDK on the thing or device, together with obviously authentication and authorization of connectivity from the device to the AWS IoT service, triggering a rule in the rules engine, and then making use of AWS Lambda with the associated execution role and policy to trigger that third-party service API. Additionally, we showed a second demo, which was around persistent state data stored within Amazon's DynamoDB service, which many of you will know is our non-relational database service. And in this particular application flow, we're sending events from the AWS IoT service directly into DynamoDB. And we also had then a static JavaScript and HTML dashboard stored in an Amazon S3 bucket. It's a simple storage service acting as a web server for this particular application. And that dashboard connecting back to that DynamoDB table and showing in real time activity level on the IoT buttons that had been deployed at this particular point in time. So that's a serverless data display application, gathering data from the AWS IoT service and rendering it for users. I'm going to jump out of the presentation now and show you some video and a quick screencast of getting started and using the AWS IoT button, just to give you a taste of the interface for this service. So we're here logged into the AWS console, and we can see here we're operating in the North Virginia region, which is one of the regions where the AWS IoT service beta is active and available. And if we click into the AWS IoT subconsole, which you can see here, you can see the entities associated with my AWS IoT button. We have a button policy, which shows the IAM policy that is attached to this particular device, which you can see is a permissive policy that permits this device to work with all actions under the IoT API scope and to work with any resources. We have the thing itself, which is the IoT button in this case. You can see details of the configuration for this specific device here, including some details on its shadow, which we're going to return to later. There is X509 certificate that you can see here. You can download the X509 cert by clicking this button here if you wish to do so. But most importantly, you can see that the identity associated with this X509 certificate is associated with the policy and also with the thing itself. So when a connection is made using this specific X509 certificate, it will be associated both with this specific device and with this policy, enabling this device to perform actions that are specified within the policy. And then we have our rules. So this is the AWS IoT rules engine that is associated with this particular device. And you can see here that we have one action associated with this device at the moment, which is an SNS action. And if we take a look at that, you'll see that triggering this rule will cause an SNS action to be taken, which will actually send an email to a specific external account. So now take a look at the IoT button hardware, show you how the hardware looks and what happens when we press our button. This could be an extremely short segment of the video because there's not very much to show here, but this is the physical button itself. You'll see it's a very small device, just large enough to hold a battery capable of supporting about 1,000 presses. It has an integrated microprocessor in it, of course, and it's Wi-Fi connected here. When first setting up the button, you hold down the button for a few seconds. It puts it into access point mode. you will connect a browser to the button, and that enables you then to rehome the button onto a specific Wi-Fi access point of your choice. A very simple demo here, of course, is just to press the button. You can see then that the button starts to blink. The device is actually booting at this point from solid-state storage, and that green light indicates that it's successfully connected to the MQTT endpoint and dispatched its message. And that's it really. There's very little more than that to show. So if we quickly check the email address associated with the SNS topic that was linked to this particular device, you'll see that we have an email here that was delivered a few minutes ago after I pressed the button that contains the payload from the MQTT message that was sent from the button on click. Now the payload contains 3 attributes: the serial number, which you can see here, the battery voltage on the button, which you can see here, and the click type, which actually has 3 different options: single, double or long. And here you can see that we just quickly press the button, so we have that. So that concludes that quick demo. Let's jump back to our slides. Before we close up today's session by talking about pricing for the AWS IoT service and the hardware program, and hopefully take a few of the questions that you've submitted during today's session, there are a couple more features that we're going to cover. The first of these is the AWS IoT Thing Shadow, and this feature enables you to create a persistent virtual version of each device, which is known as a shadow. This includes the device's latest state, and applications or other devices can read messages from the device and interact with the device when it's not actually connected to the network or potentially powered. The device shadows persist the last reported state and the desired future state of the device, even when the device is offline, and you can retrieve that last reported state or set a desired state through the API or by using the rules engine at any point, even while the devices are not connected. And the flow looks a little bit like this, so even if your device is offline, you're able to access it. The device publishes its current state to the AWS IoT service endpoint, and by doing this it maintains its current state in the device shadow. That is then persisted in a JSON data store, and apps can request the device's current state and they'll read it from the shadow. They can also request a change to the state via the shadow, and when the device becomes available again, either on the network or in a powered state, and the AWS IoT SDK is once again running on the device, the device shadow will sync the updated state into the device, and the device will then publish its current state backwards, and the device shadow at this point will confirm the state change back to the application. And this representation allows you to work with devices that are not permanently online or are not permanently powered. So it can be a very useful component in helping developers avoid some of the heavy lifting associated with building distributed connected device applications at scale. And in the device shadow feature, the different components of the system have specific roles. So the AWS IoT SDK that's running on the thing or on the device is responsible and performs functionality to report its current state to one or multiple shadows and to retrieve its desired state from the shadow. The shadow itself reports the delta, desired and reported states along with metadata and version info, and applications that developers can create can then set the desired state of a device, get the last reported state of a device, or indeed delete the shadow if that's a piece of functionality that's required. As we said earlier, the AWS IoT device SDK makes it easy for you to build shadow functionality into your device so you can automatically synchronize state. We will touch upon SDKs later, but we have SDKs available for C and for device-side JavaScript that you might use on embedded Linux-style devices. And we also provide MQTT topics that represent the device shadow to update, get delta data, to get the shadow state, and also to delete the shadow via MQTT topic subscriptions. That's functionality that's available for your apps as well. And this functionality is included within the AWS IoT button. So there's a device shadow for the IoT button. I'll do a quick demo right now showing the effect of updating the shadow in the AWS IoT Console. and the physical effect on that when we activate our button and connect it to the service. I'm back in the IoT console here looking at the device details for my IoT button. You can see that's highlighted just here. And you'll see that the shadow state is represented here in the device detail panel and that my shadow is out of sync. And in fact, there have been 4 versions of my shadow today. I'm going to update the shadow by hitting the Update Shadow tab here, and I can here via the console set the shadow state. I hope you recall on that previous slide that the shadow state here is a sequence of a series of colors. So if we, for example, go red, blue, yellow and purple and then update the shadow, that will be saved into the shadow status. You can see my shadow version is incremented to 5 and my shadow state is visible here, showing both the desired sequence and the delta with the current known device state. Jump back out of here and show you a quick video now of what happens when we press the button and retrieve and synchronize the shadow. So here we are looking at the button again. Just keep a very close eye on the light as I activate the button once more. You'll see once again with flash white as we connect to the Wi-Fi, and then the shadow state should be reflected in the color of the LED once that it is connected and synchronized. After that quick demo of device shadows using the AWS IoT button, I'm going to return to the final feature of the service that we're going to cover in today's session. Do please keep submitting questions if you have them, and we'll come to those at the end of the session. So, the AWS IoT registry, this service component, service feature, allows you to establish a static attribute set that you associate with a specific device. Might include things like firmware versions or serial numbers, and it may also include device-specific capabilities such as details of the sensors that might be attached to a device, maybe whether those sensors read data in Celsius or Fahrenheit if they're temperature sensors, for example. And there is no charge for storing device assets in the registry as long as they're updated at least once every 7 years. This can be a useful mechanism to enable you to manage your device fleets at scale, very low cost and efficient manner. And you can use it for service components that you may build, such as storing and distributing firmware, enabling you to perform device management features essentially, perhaps alerting the fleet or part of it that there's a firmware update available to those devices, and directing them to a specific URL in the Amazon S3 service, for example, in order to enable those devices to gather their updates. And you would use the attributes that are stored within the device registry to manage, control, and track the progress of this process. So you're able to build sophisticated device management workflows by using the AWS IoT device registry. That's the final feature of the service that we're going to cover today. So we talked quite extensively about the device gateway, about authentication and authorization, about the rules engine, about the shadow and the device registry. And we've also touched briefly on the AWS IoT API that you can use for things, for example, such as creating device keys and certificates. Last couple of things we're going to talk about are pricing, and then some of the partners that are working with us from a hardware perspective to deliver devices for organizations and developers that want to build applications on the AWS IoT service. So on pricing, the first thing to say is that there's a free tier for developers that want to make use of the AWS IoT service. That free tier includes 250,000 messages per month at no cost for the first 12 months of usage. Should point out that messages from devices to the service and messages from the service to devices both count against that 250,000 message total and are also accounted for in billing should you exceed the free tier allotment, or of course you're exceeding your 1 year allocation of free tier message volumes. And once you do that, charges apply. They're $5 per million messages published or delivered in the US East, North Virginia, US West, Oregon, and EU Island regions, and $8 per million messages delivered in the Asia Pacific Tokyo region. Those are the 4 regions where the IoT service is available in beta. It's pay as you go, and there are no minimum fees for the service. So once you exceed your 250,000 per month free messages, or you run out of the 12-month free tier period, you'll be billed according to the message volume that you're passing through the service. Excuse me. Quick pricing example for you. Here's an example with 100 sensors publishing data once per minute over a 30-day period. That's 4.38 million messages. That would be a metering unit that receives the data on the other side. There's a further 4.38 million messages that are being sent to the metering unit. And a DynamoDB table is also receiving all sensor data. That's a further 4.38 million messages that are delivered to DynamoDB. There's no cost for message deliveries to DynamoDB, but of course DynamoDB service charges will apply there that are outside this example. And the cost of supporting this particular workload would be 2 times $21.90. So what's that in my head? $43.80, sorry, would be the cost for that particular usage scenario. Okay, so that's pricing. Obviously, there's more details on that, but it is a simple model. There's more details on it on aws.amazon.com/IoT/pricing. A couple of things left to cover. So hardware, first of all, the embedded device SDKs that are available from AWS to enable device developers to prototype and establish production applications on their connected devices. We have options for development in C, which is ideal for embedded OSs such as the Arduino and other embedded operating systems. We have a JavaScript SDK, which is ideal for embedded Linux platforms such as the Intel Edison. We have Arduino libraries for the Yun and mobile SDKs for the Android and iOS platforms, enabling developers on more powerful mobile devices such as phones and tablets to build applications that use the AWS IoT service. Also at AWS reInvent, we launched the AWS IoT hardware program. This is intended to simplify access to compatible hardware for customers that want to build connected products. We have a variety of different hardware partners that are working with AWS to provide hardware such as semiconductors, connectivity modules, sensors, and actuators to customers that are interested in connecting hardware platforms to the AWS IoT service. We have a wide variety of different providers that are participating in the program. Intel, MediaTek, Seed, Studio, Texas Instruments, Marvel, Broadcom, and others. And they provide a variety of different platforms that customers can take advantage of. Intel Edison, as I mentioned earlier, with its embedded Linux, through to a broad range of devices that make use of the embedded C SDK on Arduino and on other platforms as well. So I'd encourage you to take a look at those. If you want to have further exploration into those hardware platforms, there is a section on the AWS IoT webpage where you can learn a lot more about those hardware partners and access purchasing options for those starter kits on Amazon.com, for example. So I will just point you again to that URL in closing before we look to take a few questions from you from today's session. So if you do have any further questions, please do submit those using the Q&A panel that you can see in the webinar interface. This really concludes the content from today's session, but I would really encourage you to check out the AWS IoT detail page on the AWS website, which you can find at aws.amazon.com/IoT. You find comprehensive getting started documentation there, as well as links to device manufacturers, links to our SDK documentation, of course links to our SDK repos on GitHub also. So thanks for your attention during today's session. That's going to conclude the recorded portion of this webinar, which we'll make available on YouTube. We'll, however, turn now and take a look at some of the questions that have been submitted during today's session. Thanks for joining us.